ninth chapter, probability. This chapter belongs to mathematics 2A, part A. Last part completed, impounded 4 marks or 7 marks problems completed. This problems totally belongs to independent, dependent variable and conditional probability. Today discuss very important theorem based theorem. This is very important. This theorem using problem also be very important in IP examination. In this Bayes theorem, question state and prove that Bayes theorem, sometimes asking, sometimes statement is given just to prove, you can find. Total 2 ways ask the question in IP examination. First, Bayes theorem statement is what? What is that statement? Let E1, E2, E3, and so on En are mutually exclusive and mutually exhaustive events in a random experiment. Here, in a random experiment, total n events is there. What is that n events? E1, E2, E3, and so on, En. This total n events of the random experiment. In this n events are mutually exclusive events. Similarly, mutually exhaustive events are given. After that, with the P of Ei is not equal to 0. P of Ei is not equal to 0 for I nothing but I equal to 0, 1, 2, 3, and so on n. Then for any event A or the random experiment, in this random experiment, any one event is capital A with P of A is not equal to 0. P of A is not equal to 0. Then P of Ek by A, E suffix k by A is equal to P of E suffix A into P of A by E suffix A, or by summation of I is equal to 0 to n, P of E suffix I into P of A by E suffix I. Here k value is 1, 2, 3, and so on. This is the Bayes theorem formula. What is that formula? One-sided experiment formula is what? P of Ek by A is equal to P of Ek into P of A by Ek, or by summation of I is equal to 0 to n, P of Ei into P of A by Ei. Here must and should P of Ei value is not equal to 0. Here for k is 0, 1, k value is 1, 2, 3, and so on. Here this is the statement of the in this Bayes theorem. This statement is very important. Sometimes state and prove that Bayes theorem ask. That time this statement having 2 marks. Just to you can write this statement, you get 2 marks. In this formula you can write 1 mark. Remaining theory you can write 1 mark. Okay students, after that you can write proof. What is the proof of in this Bayes theorem? First of all, what is the given? Here E1, E2, E3, and so on, En are n events in a random experiment. Which experiment? Random experiment. In this random experiment, these are the n events. In this n events are mutually exclusive. What is the meaning of mutually exclusive? The events, no common element. Suppose we have to take any 2 events, that 2 events having no common elements. That's why that is called mutually exclusive events. That's why you can write here what? Here E1, E2, E3, En are n mutually exclusive events. Then mutually exclusive events. Then you can write E1 intersection E2 intersection E3 intersection and so on E4 and so on En intersection En equal to 5. This can be, you can write E suffix I intersection E suffix J is equal to pi. Here must and should the I value is not equal to j. Here I value equal to not equal to j nothing, but here if I value is 1, j value also be 1. Even intersection even, you know that even. What is the common elements of two sets are equal sets? Common elements also be equal set. That's why here E1, here E2. E1 intersection E2, mutually exclusive. E2 intersection E3, mutually exclusive. What is the meaning of mutually exclusive? No common elements. This is the condition of in this way. After the second one is what here? Second condition, exhaustive events. Which events? Exhaustive. What is the meaning of exhaustive? In total sample space, n events is there. The combination of all events equal to sample space, that is called exhaustive events. That's why you can write E1 comma E2 comma E3 comma also on En or n mutually exhaustive events. Mutually exhaustive events. Then E1 union E2 union E3 union also on En is equal to sample space. Yes, correct or not, students? This one is correct or not? This total combination of all events equal to sample space, that is called exhaustive events. This can be written as, you can write union of E suffix I is equal to 1 to n. Correct or not? Union nothing but a combination. You can write E1 union, E2 union, E3 union, also on En. That is value equal to, yes, this is a very important. This is the point of events are the exhaustive events. This is the points of events are mutually exclusive events. These 2 points are very important. You can prove the Bayes theorem formula. After that, randomization of P of Ei not equal to 0 is given. For I equal to, here I value is what here? I value is 0 comma, here I value is 0 comma, 1 comma, 2 comma, 3 comma, and so on. Here not is 0. Next, for any event A or the random experiment, here A be the event in a sample space, yes. Sample space, yes. Then A be the event in a sample space. Sample space, how many events is there? Number of events is there. That number of events, A, you have to take any one event. Then A intersection S is equal to what? A intersection S is equal to what? What is the intersection of sample space and event? That value equal to A. Understood or not? The sample space having total values having sample space. In this total having A is one event. The intersection of sample space and event common element is equal to event A. After that, you can write A value, A intersection. You can write S value is what here? Union of I is equal to 1 to n E suffix I is equal to A. Here A intersection S value is by the mutually exhaustive events. S value is union I is equal to 1 to n, E I is equal to S. This is also been given. After that, you can write union of I is equal to 1 to n. A intersection E suffix I is equal to A. Here you can write this union front side. Union I equal to 1 to n, A intersection E I is equal to A. Okay, students. After that, here A intersection E I intersection A intersection EJ value equal to pi. Why? Because here A intersection EI and A intersection EJ are mutually exclusive events. Which events? Mutually exclusive events. Here the intersection of A intersection EI and A intersection EJ value equal to pi. These two events are mutually exclusive events. That's why you can write this is. After that, you can apply this one is probability. This function having probability P of union of I is equal to 1 to n A intersection EI is equal to P of A. P of nothing but probability applying on both sides. After that, this union probability union nothing but combination. That is also written as sum of the terms or not. That's why you can write this union goes to a summation. Summation I is equal to 1 to n P of A intersection EI is equal to P of A. Understood or not, friends? Here union nothing but combination of all events, sum of the all events. That sum also you can use symbol summation, union, sum, both are equal here. That's why you can write by the multiplication theorem on probability. Multiplication theorem on probability. What is the multiplication theorem? P of A intersection is equal to P of A into P of B by A, that is equal to P of B into P of A by B. You can write in these two formulas any one formula that is your wish. Here, see students, here P of summation of I is equal to 1 to n. You can write P of A intersection B. This is A, this is B. P of A intersection B equal, you can write this formula, you can write this formula. Which formula you can use? You can use P of B into P of A by B formula. What is the P of B? P of B nothing but P of EI into P of A by A nothing but A by A nothing but A by B nothing but B suffix I is equal to P of A. This can be written as P of A is equal to summation of I is equal to 1 to n P of EI into P of A by EI. Suppose you have to take this is equation 1. After that, you have to take LHS part of the formula. What is that LHS part? P of E K by A. Here for K value is what here? K value is 1, 2, 3, and so on. P of E K by A. Here you can use conditional probability. Which probability? Conditional probability. What is the formula of conditional probability? You know that formula. P of A by B is equal to P of A intersection B by P of B. This formula is there. Or P of B by A is equal to P of A intersection B by P of A. You can write in these two formulas. Any one formula you can use this. Here suppose this one is what here? This one is A, this one is B, P of A by B formula. What is the P of A by B formula? P of A nothing but E suffix K, intersection B nothing but A by P of A. Once again, numerator A intersection B form is there. A intersection B form is there. P of A intersection B, in this numerator you can use a multiplication theorem on probability. In this multiplication theorem on probability, you can use which formula? First formula, P of A into P of B by A. You can constants here P of EK by A equal to here P of A intersection B. You can use first formula. In this formula, A value is E suffix K, B value is A. You can write the A value P of E suffix K into P of B by A. B value what is it? B value A by E suffix K whole by P of A. You know that P of A value. What is that value of P of A? In this equation 1. What is that value of P of A? You get P of E suffix K of A equal to P of E K into P of A by E K. Or by P of A value is what here? Summation of I is equal to 1 to n P of EI into P of A by EI. Here for K is equal to 1, 2, so on n. Similarly for I is equal to 1, 2, and so on n. This is the theorem of Bayes' theorem. This theorem is very, very important. Repeated problem in IB examination. This proof and statement. This theorem dependent problem also be important in IB examination. You can read and write the practices perfectly. You get easily understood in this theorem. Okay.